Saw the thumbnail and the title. It's probably clickbait. You know what this is about. We're building the most ridiculous HomeLab HL 15 45 drives chassis. 128 cores. Terabyte of RAM? We'll see. It's gonna be nuts. So, quick question. When you build a HomeLab PC, or you're building something that's a permanent fixture in your house, what's the most valuable thing? In my experience, it turns out that's the case, or your physical plant infrastructure. Your wiring, what you do for a rack, that sort of thing. And it kind of makes sense. When you install an electrical panel, the electrical panel should be good for 20, 40, 60, 80 years. I mean, North American wiring standards really haven't changed much since the late 1970s, early 1980s. I mean, okay, a little bit. They started adding ridiculous stuff now, like arc fault interrupters and circuit breakers that have chips in them that are overly sensitive to people doing mad science in their house. That's neither here nor there. But by and large, it doesn't change. I would argue this system, the 45 drives HL15, that I saw in person in Nova Scotia a little while ago, is going to outlive the system you put in it. It's probably going to have 3, 4, 5 systems in it. How do I know? Because I have systems that I built over a decade ago that are still in service in one capacity or another, and their guts have changed. I've got super micro systems where the power supplies are on their last legs and they're proprietary. But because the motherboard was that fledgling ATX standard, I've put in all manner of upgrades and replacements. This is kind of like that. The quality of life here is that you have 15 places to mount 3.5-inch drives, 3 high airflow, low noise fans at the front, a pretty good airflow design, standard ATX power supply, standard ATX motherboard. And yeah, if you want a redundant power supply, you can totally do a redundant power supply. Remember FSP Group? They make a power supply that'll fit in here, no problem. If you want that, go ahead and do that. That's totally fine. You might also be noticing, wait a minute, did 45 Drives send you just an empty case? Yes, they did, because that's one of the things that you can buy. Because it's an empty case. This was my selection. I picked this. So when you order it, what do you get? Well, you get the box, the chassis with the power supply. You can order it without a power supply. This, in our case, is a Corsair RM750E, and we are going to be pushing every single little watt of that 750 watt power supply. I may end up having to upgrade it. We'll see. That also means you're getting a 15 drive backplane, a total of 6 fans, power button, and there's mounting spots for 3D printable accessories that you can put in the case. Also in the box, you get congratulations on becoming an owner of an HL15, the person who assembled it. Thanks, Shane. And a QR code and some other stuff to get started. A password for your system if you happen to opt for like the full build or whatever. And a packing list. There's also a box that contains lots and lots and lots of cables for your power supply. Now the front connectors for the drives, the power for that is 45 drives. Proprietary, but it plugs into the standard Corsair connector. So if you get another power supply, you're going to want to use Corsair so that you've got the standard connector. Although it does have Molex connections, so you can use a standard Molex connection, but I like that the Corsair wires are short and neat. So in your accessory box, you've got all kinds of cables, including... This is the NVIDIA RTX breakout cable. So if you wanted to put a GPU in your HomeLab server for transcoding or even VFIO gaming, you totally could. NVIDIA vGPU unlock, yeah, it's a thing, but not on the most recent cards, sadly. You've got a bunch of zip ties. You've got feet. So this is a rack mount case. I ordered it with the rack rails. We've seen those before. But you can also configure this in a tower configuration. Because of the danger of, a cat or something going by and bumping into it and knocking it over with lots of mechanical spinning rust inside, would not recommend tower configuration for anywhere that there's any danger of the system getting moved. You can put the feet on the bottom as well, so if you want to use it in a desktop configuration without the rack rails, that's totally an option. The case dimensions are here. So you can see this is basically a short depth rack setup. So with a short depth rack setup, there's a lot of options if you want to go full rack mount or HomeLab rack mount. They also include a power cable and the front rack brackets, so you can screw it in. You get the front rack brackets whether or not you get the rails. So you can always screw it in as long as you put it on a shelf or on the bottom or something. The reason that I'm so excited about 45 Drives is because I physically went there. They're a small company. They are doing the open source thing right. They have got a lot of options around Ceph and the enterprise and building high availability clusters. If you wanted to build a 3-system cluster out of this chassis, they will help you do that. And that is high availability to the nines. That is an incredibly nice setup. And they really have done the work in terms of the plumbing and engineering necessary to support an open source project. With most open source projects, you don't really, it's not like you go to GitHub and you download the source and then you're off to the races. There's a lot of work that you have to do yourself. And they have really put in the work to dot the I's and cross the T's for their customers. That's part of the reason why I went there, is because they've been such good stewards of open source is the best way that I can summarize their behavior over the last 3, 4, 5 years. And because of that, they are displacing a lot of other, traditionally enterprise, fully proprietary software solutions that exist out there for storage. So 45 Drives really should be on your radar for any kind of lots of enterprise storage or even high performance storage. High performance Ceph is, almost an oxymoron, but the software and the platform and the investments that are happening around Ceph are pretty well realized in a 45 Drives based solution. So that's really awesome. But this is the HomeLab product. So this is something a little different. It's physically smaller. It's designed for 15 drives. And it's designed for you to, you can buy a full system turnkey from them, just add hard drives. Or you can do like I did and pick up the chassis because you see the chassis is, more valuable. You're going to put in your own hardware. Plus also this being, level 1, I'm gonna take something home from work. I managed not to do this with the Milan generation, just in supporting people working on their PhD and open source projects and everything else. Every single Milan CPU that AMD sent me is doing something for somebody somewhere, which is pretty interesting. But I've got a 128 core Bergamo CPU, and the instructions specifically, these are for data centers only. Okay, fair enough. It's going to my home data center. So I've got one here at the office for testing, and this one, it's going in here. The 9754, 128 cores. Whew, man. I don't know that I would recommend this, but this is what I'm going to do. So the question then is, what would you recommend? This is the Gigabyte MW34 SP0 that I've reviewed previously. This motherboard is a reasonable W680 motherboard. It was one of the first W680 motherboards. There are some newer ones, but this one is DDR4 instead of DDR5. So you can run more DDR4 memory at a higher speed, ironically, when we're talking about 4 DIMMs on a DDR4 platform. As a practical matter, I don't know if that actually means that the DDR4 platform is faster than the DDR5 platform when it's fully populated, talking about 128 gigabytes of memory. Theoretically, the DDR5 platform should support 192 gigabytes of memory. You will not get that on the DDR4 platform, but there you are. This W680 motherboard enables unregistered error-correcting memory to work with i7 and i9 processors. For the MW34, I do not recommend K processors. This motherboard cannot deliver the wattage for those higher-end parts. A CPU like a 12700 non-K with its 8 performance cores would give you heaps and heaps of performance here because the single thread speed is just so bananas. And 64 or 128 gigabytes of memory in this platform, that's a pretty incredible home lab platform for not a lot of money. In fact, there was some problems with the MW34 that some users on our forum encountered with the V1.0 of this board. And because things were a little squirrely, I ended up ordering 10 of those motherboards to experiment with. I've finished those experiments. The video on that is not done yet. But if you'd like an MW34 motherboard from Level 1 Techs, they're on store.level1techs.com for around $500, give or take. Maybe as time goes on, those might get discounted. I don't know. It's a little bit like we're not making any money on those. It was just for a Level 1 diagnostic. I wanted to buy a lot of motherboards to see, hey, what happens? And those are the revision 1.1 of that motherboard. So look for my testing report and all that kind of stuff on the MW34. It's an interesting board. It's an interesting board for Alder Lake LGA 1700, 12th and 13th gen processors. fun stuff. But I digress. We recently reviewed an AM5 motherboard from ASRock. This has one X16 slot and one X4 slot, as well as one X1 slot, but it also has built-in 10 gigabit Ethernet. That would be a fantastic choice for this platform. 2 reasons. One, you're probably going to end up needing an HBA to connect all 15 of your drives. A PCIe add-in card like this one. This one is only 8 drives, but this PCB supports up to, there's another version of this PCB that has 4 of these square connectors at the end, and that'll happily support 16 drives. You want an HBA. You do not want a RAID controller. And I'm sure 45 Drives will be happy to sell you the appropriate LSI controller. That's neither here nor there. But this interface, even though it's by 8, it will work in a by 4 slot. Now, for the drives that I'm putting in here, they're really high performance, but if you are relegated to PCIe 3.0 by 4, that means this card is going to run at a maximum speed of 4 gigabytes per second. With a 10 gigabit Ethernet interface, you're looking at 1 to 2 gigabytes per second anyway, depending on if you use one or both of your 10 gig connections. Even a 25 gigabit Ethernet connection is not necessarily going to be saturated or produce a situation where the HBA is the bottleneck with a 25 gig Ethernet solution in an X4 slot. That means your X16 slot is free for other things, like a GPU for transcoding or whatever. But if you're using a GPU for transcoding, the GPU would also be pretty happy in that X4 slot, but then you're in a situation where you physically need a GPU. It's only one slot, and a one slot GPU that's actually pretty powerful is a little bit of a challenge. A lot of NVIDIA gaming GPUs also have an unlock where you can run multiple transcode streams at the same time. Typically, that's limited to 3 transcode streams at a time, but there's an unlock, and you can run 8, 12, whatever. It's pretty well covered on the internet. I don't need to get into the details of that. It's a thing that exists that maybe should be on your radar. So if you would, imagine that micro ATX motherboard on the inside here. You're going to have a lot of extra room because you've got room for full-size ATX and eATX motherboards in this layout. There's some pre-installed standoffs in this case. So that AM5 motherboard, it supports unregistered ECC UDIMMs, so 64 gigabytes of ECC UDIMMs are pretty readily available at the time that I'm doing this video. Theoretically, you could do 96 gigabytes of memory, but I haven't seen a 96 gigabyte dual DIMM kit that is unregistered error correcting memory. You can run non-error correcting memory because DDR5 has a little bit of error correction built in all the time no matter what, but it is better still to get the actual ECC UDIMMs. For server platforms, registered error correcting memory, RDIMMs. That's where we're going. We will not be using the MW34 or B660 or anything with 16, 32 cores. You can forget it. Now I hear you. I hear it's you're really talking me into the 128 cores. You don't have to be that insane. An option for something that is vastly more powerful than W680 or AM5, if you're looking for a deal, is old Threadripper, a 3000 series or a 5000 series Threadripper. Okay, everybody's still trying to get their hands on 5000 series Threadripper, even though 7000 series Threadripper is out because 5000 series Threadripper was so expensive for so long. But the 32 core Threadripper Pro is pretty obtainable, and those motherboards have remote management, which you need in this context. And you can get some really amazing CPU coolers like the Arctic 4M for cooling a Threadripper Pro. So throwing a Threadripper Pro motherboard in this system to use as a workstation server kind of thing is actually pretty hot. If you do decide to do that, I highly recommend the Arctic Freezer 4U-M. This is a new version of this cooler. This is one of my favorite coolers for SP3. This updated version of the cooler is my favorite cooler for SP3, especially for motherboards that have the, horizontal socket like Threadripper Pro. And I can confirm that it fits in this case with plenty of clearance. Now, unfortunately, the new Arctic 4U-M, it doesn't work with Genoa processors, or Bergamo for that matter. I'm going to have to machine my own mounts for this. For now, I'm going to be using a Dynatron cooler that's designed for Bergamo and Genoa. It unfortunately sounds and works like a weed eater on the struggle bus. You might be wondering, which board have I picked? Well, I'm going to use the ASRock Rack G5FSWR00562. This motherboard is really designed for low-profile NVMe. Now, this motherboard comes with an interesting cable that's MCIO to 8 SATA. There are 4 MCIO connections on this motherboard, 2 of which are pure PCIe. The other 2 support SATA mode. So this motherboard will support 16 SATA devices natively. But the cables that are bundled with our 45 drive system and the cables that are bundled with the motherboard don't really help us, because the cable for the motherboard is pure SATA and the interface for the motherboard is SAS. And this is actually another really important lesson you should consider when you're building this system. Some motherboards do actually have the square mini SAS connector style that this chassis uses, but not a lot of motherboards can drive the signal through the full length of the wire. There's nothing as good as a standalone HBA card. And this is one of the reasons why 45 Drives tends to want to bundle an HBA card with their systems, is because this does, like signal integrity, redriving, etc., etc. And even though this is technically serial attached SCSI SAS controller chips can also speak the SATA protocol. The reverse is not true. You can't plug a SAS drive into a SATA port and expect it to work. Electrically, there are some differences between the SAS and SATA signaling. Technically, the setup that we have is designed for SAS signaling, and with SAS signaling, you can get along with longer cables, and SAS is more forgiving than SATA. With SATA, you can have weird, hard-to-diagnose problems if you don't get everything exactly right. In our case, for this server motherboard, I'm going to roll the dice and use some cables to go directly from the motherboard to the backplane eventually, but that's going to be a separate video and actually an entirely separate set of testing, because that is such an interesting mini rabbit hole to go down. I'm thinking on this historically. This was the whole like SATA versus SAS versus cabling was kind of a portent of things to come with PCIe cabling. We still have that thread on the Level 1 forum where we've been suffering a lot. Things like PCIe bifurcation adapters and 4 NVMe to a PCIe slot. And is it Gen 3? Is it Gen 4? Is this a Gen 4 cable? When I'm trying to use like the P5800X Optanes that are insanely expensive but also insanely fast, and I need to, cable them in, I have to use special redrivers and special cables. It's really hard to find those that actually work. Well, a mini version of that level of suffering was happening with SATA and SAS. For people that were into SATA and SAS, there just weren't that many people. But now, it's 2023, 2024. This is a thing that can exist on YouTube and everything else. Fun times. I love this motherboard. It's so cute. It's only 8 memory channels. And yeah, I would like to use 12 memory channels with 128 cores, but for what I'm using it for, it's not going to be hobbled. We're going to run a lot of virtual machine workloads. We'll talk about that later. I've got 4 PCIe Gen 5 slots. Our M.2 is Gen 5. This whole board is Gen 5. This board is engineered to the nines for PCIe Gen 5, but it's a tiny little motherboard. Look at this. It's about 10 inches and change by 10 inches and change. It's the Genoa D8UD. Genoa. That's just so cute. In the blue bag are the motherboard standoffs. You'll want to use those. You don't want to screw the motherboard directly to the bottom of the case. That would be bad. There are standoffs from Micro ATX. Good job, 45 Drives. Nicely done. This is technically a Micro ATX Genoa board. What madness is this? This is just ASRock showing off is what this is. Oh, we can't do it without 27 PCB lanes and blah, blah, blah. ASRock's like, hold my beer. One other fascinating thing that you might notice about this motherboard is that it doesn't have a standard 24-pin power connector. It's too big. Takes up too much room. Included in the box is a special 24-pin power adapter where it only really gets a couple of lines from that connector. It really only needs ground, the power on signal, and a couple other pins. And that's basically it. It relies heavily on the 3 400-watt 12-volt connections, which is going to be a little bit of a challenge with our Corsair power supply. We've only got 2 CPU 8-pin. Fortunately, I can adapt a GPU 8-pin to a CPU 8-pin, which those actually do have different pinouts. Don't force it. You need an adapter cable. So I've temporarily set up a Supermicro sort of full ATX and then some motherboard to show a couple of things. I've also taken out the mid-bar fan thing. Look, they're using 3D printed stuff in their drive holder and the fan accessory thing. That's pretty clever use of 3D printing. But I had to take all this apart in order to show some very important things about the setup here. Because if you're like me and you want to do this without an add-in card or an HBA to connect those mini SAS HD connectors, you're going to need to know some important stuff about this setup. First of all, the connector here on the motherboard is MCIO. And MCIO is sort of a new standard. It can support up to PCIe Gen 5, but in our case, we're just using it for SATA. And so I've got a breakout cable that goes from MCIO to 8 SATA that came with the motherboard. But our backplane from 45 drives also uses the mini SAS HD connectors. And just because the cable has each connector on each end, it doesn't mean it's going to work. So I got an MCIO to mini SAS HD cable. There's a link in the forum thread for known working with their HBA cables. And just because it worked for me doesn't necessarily mean it's going to work for you. 45 drives can't test every single possible cable combination. But for me, so far, it's working well on both Supermicro and ASRock motherboards. The aforementioned ASRock Genoa 8U, 8D, UD, whatever the motherboard was I was looking at earlier, that has 2 MCIO connectors. Here we have our single MCIO connector to our dual mini SAS HD. So this connects to the 45 drives backplane, and this connects to our motherboard. Now, our ASRock motherboard actually uses 2 of these, whereas our Supermicro motherboard only uses the 1. Now, our Supermicro motherboard, even though it's got 3 of those MCIO connectors, only 1 of them is supported for SATA. The other SATA ports are broken out into normal SATA headers. And you might think, hey, SATA to mini SAS HD, motherboards come with that. I can use that, right? No, those cables are not reversible. You need what's called a reverse breakout cable, and even that is not guaranteed to work. This is the mini SAS HD to SATA cable. 99% of these that you would buy will not work. You need what's called a reverse breakout cable. It'll look like this, but it's designed to go from the motherboard on this side to backplane on this side, and that's the part that's unusual. So definitely do your homework if you're going to color outside the lines and not use an officially 45 drive sanctioned HBA. In other words, it's worth the price of admission to just buy the known controllers and cables that work, unless you're willing to be like me and experiment a little bit and try to find a more optimal solution. Because with a motherboard like this, I can actually break the MCIO out into NVMe as well, and without having any add-in cards whatsoever, drive 15 SATA drives and 4 U.2 drives just directly from a platform like this. Oh, the other thing is the front set of screws in this motherboard, they're going to be right up against your fan grill. There's not actually mounting points for that. You can use plastic standoffs or 3D printed plastic standoffs. I think 45 drives could include some 3D printed plastic motherboard standoffs, or you can get a 5-pack off of eBay for like $3. So it's just little plastic pegs. In this case, for the Supermicro motherboard, you don't even really need them. Like, you're going to have plenty of clearance in the case, but just something to be aware of, because this is a HomeLab system after all, and it's not designed for insane monster motherboards. Everything is set up and ready to go, but a note when you're building a system like this, I'm using those MCIO SATA breakout cables, and everything is great with that, but your drives are not necessarily going to be auto-detected. You actually have to set a BIOS option. You have to explicitly pick SATA in order for your drives to show up, and then save and exit. The BIOS options are going to be different on every different board, but that's one of the magic things about AMD EPYC. See, it's got lots of lanes you can use for SATA, PCIe, what have you. And I've still got 2 MCIO lanes free, so I can add up to 4 NVMe even before I touch the slots. And even though this motherboard isn't super big, I can have a GPU, a 3-slot GPU, hanging off of the end of the motherboard without blocking any of my other PCIe slots. It's pretty cool stuff. I'm not kidding when I say that I'm going to be using this chassis well beyond the power supply, motherboard, and drives that are in it now. So what's the final configuration? I'm so glad you asked. Here it is. 128 cores, Bergamo. We've got tons of dual actuator 18 terabyte Seagate Exos hard drives. I've all taken a look at these things separately. We also got our Kioxia CM7 PCIe Gen 5. Now I want to make really explicitly clear that with our ASRock rack motherboard, we've got 4 MCIO connections. I've got all of the hard drives connected, plus 2 Kioxia CM7, plus 2 Optane 900p for my ZFS metadata special devices, and I haven't used a single PCIe slot yet. It's got onboard 10 gigabit, but this might be one of the only systems that features both Mellanox ConnectX-5 and Intel OmniPath, both 100 gigabit interfaces. OmniPath is a very special interface for HomeLab because you could build a fully connected cluster without having an OmniPath switch. You can pick up a bunch of these cards. They're $20 to $30, or they have been historically, on eBay. And then you connect this card directly into another card. So if you wanted to build a 3-node cluster, you put 2 cards in each machine, and then you just connect each node directly to each other node. If you wanted to do a 4-node cluster, you could do it with 3 cards. In my case, I'm just connecting this to the OmniPath switch that I took a look at previously at 100 gigabit. That's 10 gigabytes per second. And I've got a Mellanox card as well for 100 gigabit Ethernet. And so I can cross over. I can build a switch basically to switch between Ethernet and OmniPath. There's no practical use for that other than it's a lot of fun. Now, I've had a lot of fun taking a look at your HomeLab setups in the Level 1 forums and elsewhere. The pictures are amazing and what you're doing is amazing. And it's like, I'm going to turn trash into something amazing. The shipping configuration from 45 drives is serious. You can saturate dual 10 gigabit Ethernet with the hardware that they ship you. If you like to get the motherboard and the basic chassis config, it's plug and play. It couldn't be easier. If you're like me and you want to go a little bit more off-road, I ordered this configuration just as a bare bones chassis. Now, they declined to let me pay for it, but this machine will work perfectly fine from now until the end of time because there's no rivets at 16 gauge steel. I fully expect I'm going to end up changing the hardware and contents of this system 2 or 3 times over its lifetime, and it's probably going to show up in other videos on the Level 1 Tech's channel. Now, one of the other things that I took away from your HomeLab setup, you guys do much the same. If you pick up this chassis, even though, it's north of $1,000 just for the chassis and the backplane and the connectivity, it's probably something that you can use for 5 to 10 years. So it's going to have better longevity than pretty much anything else that you would buy. But the second thing is that you don't have to put new stuff in there. I mean, 128 core Bergamo, this is literally the best of the best of the best. And normally you wouldn't even put a high core count machine in here. You would put something with an insanely good clock speed so that it runs really fast with your networking. It's just that Zen 4C is so fast that 100 gigabit is slow. So from the point of view of Zen 4C anyway. Some of your best options? This is an Epic Rome motherboard. Epic Rome CPUs are starting to show up on eBay, and Zen 2 still kicks hind in 2023. Now, the Epic Rome CPUs, they are clocked a little slow. Like, you could run into problems theoretically at 100 gigabit. At 10 gigabit, come on, it's fine. You're going to be 100% okay at 10 gigabit. But, remember Threadripper and Threadripper Pro? 3rd gen Threadripper, 3000 series Threadripper, is also starting to show up in secondary and used channels. And this, as a platform for your HomeLab system, is pretty much unbeatable. It has insanely high single clock speeds, as well as a bunch of cores, if you want a bunch of cores. This only makes sense beyond 45 drives HomeLab configuration if you work in IT, or if you want to turn this into a hobby project and do a bunch of stuff with your system other than storage. And actually, the HomeLab's configuration from 45 drives can do a bunch of stuff other than storage. For me, for this configuration, I've only got 4 expansion slots. But like I say, even before I've done anything interesting here, I haven't even touched my expansion slots. I add dual 100 gig Ethernet. Okay, that's fine. I add 2 more M.2. Okay, that's fine. This box can hold 300 terabytes out of the box without me doing anything special between flash and mechanical storage with just 15 mechanical drives. And these dual actuator drives are so insanely fast that it'll run everything. The only thing that's really left is single point of failure. And this is one of the things that I see in your HomeLabs where it's just like everyone has to suffer under your upgrades and updates and everything else. We've covered the forbidden router. It turns out this platform, whether 45 drive shipping configuration or if you go over to the top with Threadripper Pro or something even well beyond Threadripper Pro, works really well for high availability clusters even if your system is not homogeneous. So remember the N100 forbidden router that we did? If you use Proxmox for your host operating system, for example, and you don't have to use Proxmox, you could use literally anything. You could do this with OpenShift, you could do this on Red Hat, there's a lot of options. You run a virtual machine on here for your router, and you run another router in high availability mode on the N100. Same thing with media. If you have a wireless access point controller, etc., then you don't have a single point of failure. But wait, you say, my ISP modem only has a single Ethernet port. How am I going to do that? VLANs. So we're working on another forbidden router video with our 45 drives chassis plus our N100 chassis. And so with a switch like this, where you've got lots and lots of gigabit connectivity and maybe some SFP plus 10 gig uplink ports, you can partition these off. You can actually plug your modem directly into the switch. Now technically the switch becomes a single point of failure, but you can actually run dual switches and get creative to make the switch not a single point of failure. But switches, your ISP modem is more likely to die than your switch. You set up a VLAN just for the ISP side, and it's transparent. It's just like a cable. And then that goes into your high availability setup. So that same VLAN is connected to both systems. So you have your 45 drive system and your N100 forbidden router system that's also running Proxmox. And then each one of those is running a, pfSense or OpenSense router VM at the same time. And that software is configured in high availability mode. It's not that you're relying on your virtualization software for high availability. You're literally doing it in the application that supports it. pfSense supports this really well, and I've done it a lot with pfSense. I think OpenSense reasonably well supports it, and with your routing software configured with the same MAC addresses and everything else, your pedestrian home ISP isn't going to know anything has happened. And then if you need to take this down to do maintenance, the rest of your family in your house is not going to suffer as you do maintenance, and you don't have a single point of failure. I mean, yeah, every episode of Star Trek going back to the beginning of time might not be available because the storage pool isn't available, but at least the wireless and the internet and DHCP and your guest portal, maybe music streaming, and your home assistant, that sort of thing can just keep right on trucking. Because I've sort of come to rely on the smart home assistant, and I don't want it to be down. So high availability in this platform is really something else. And overall, I like what 45 Drives has done with the HL15. It's also available, like the AV15. And you can build clusters out of these, obviously, if you wanted to get 2 or 3 of these, not in a home lab scenario, in like a research lab scenario. Obviously, that's an option. But yeah, this is really something special. 45 Drives has done a good job putting this together. And I'm shocked that I was able to not even have an HBA and have that work. Like I say, your mileage on that may vary. I've gone way off the reservation here. If you want something, set it and forget it. Just buy the whole kit and caboodle from 45 Drives. You can plug in a drive and you're good to go. But if you're going to go off script like I am, it's a lot of fun. Just be prepared for, some cuts and bruises as the bleeding edge. I'm Little, this is Level 1. I'm signing out. You can find me in the Level 1 forums.